distribution, the same as in the case of mirror. Okay, take the screenshot. What are the information that we will get? Right, important points. First, if M is positive, what does it mean? If M is positive, then the image is
Enlarged.
the image, huh?
Enlarged.
Enlarged is decided by the value of M, whether it is greater than or less than or equals to 1. Okay, but the sign of the M decide whether the image is virtual, erect, or real or inverted. So if the M is positive, the image is, what the image is then? What we have seen in the case of mirror. Huh? When the M will be positive, you see that the formula is when the M will be positive. You cannot be negative or positive. So this means V should be negative. If the V is negative, this means the image is forming where? On the negative surface. Let's when it get happen, when the image is virtual and erect. Have you got this? Similarly, if M is negative, then U is always negative, V is positive, then image is real and inverted. Have you got this? Third, if M is less than 1, then image is diminished. Okay. Fourth is if M is greater than 1, then image is enlarged. Fifth, if M is equals to 1, then image is same in size than as object. Have you got this, beta? Hmm?
Yes, sir.
Okay. Take the screenshot. Have you taken? Okay. There is also a relationship between focal length and M, magnification. Have you got this, Peter? There is a relation between focal length and M. What relation it is? What is F? Formula of for F, if you write, it is will come out to be VU upon U minus V. Huh? Will it come out to be this or not?
Yes, sir.
Hmm? What M in terms of U and V? Have you got this?
Yes, sir.
What we can write V in terms of F over here from here. Or from here, if we write V or U in terms of F, what we have to write then? What we can write? Hmm?
Reciprocal.
Okay, initially, the formula was for focal length. This was the formula. Huh? We
Yes,
take the
sir.
LCM. We take the LCM. What the LCM will come out to be, let us say, UV. Here it will come out to U like this. Or we just take common 1 by V from here. 1 by V we take common, what will remain? 1 minus V over U. Okay, we can do this. Okay, we have taken 1 by V common from here. We can do this. Then V over U can be written as 1 minus V over F. We can write this. Can we write this? We have taken 1 over V common from these two terms. From these two terms, we take common 1 over V. What remain inside? 1 minus U over V over U. We have bring this, or have to write all the steps. It will be like this. Huh?
Yes, sir.
Then we bring it to this side and take this to this side. What will happen? V over U is equals to 1 minus V over F. Can we write this? And if we put M is equals to V over U, we have seen from here, we put over here 1 minus V over F. Okay, then M is equals to F minus V over F. Okay, this is the another relation. Or in terms of U also you can write. Take 1 by U common from here, then it will change according to that. U minus F upon F. Okay. Have you got this, beta? Take the screenshot. Taken. All of you are writing together. Write a question quickly. Can you do this? All of you can see the question? Can you do the question, beta? Have you done? Done. Have you got the question? Find the refractive index of the material of lens and magnification. So easily you can find the magnification. For finding the refractive index, you should know the radius that has been given to you and focal length. Okay, that also you can find easily by using M or by using. Done, beta? Have you done or not? Here we can find F, M in terms of V or U, F by using this formula in terms of V and U. And refractive index is there 1 minus N minus 1 upon R1 minus R2 1 by F. By using this, we have to find n. Okay, refractive index of the lens. When we are talking this, then we are talking about the refractive index of the lens with respect to that medium. Okay, so we can find this. Only these three formulas will be. Have you got this, beta? What, beta? Refractive index for the convex lens. Refractive index will be positive. Yeah, magnification can be positive or negative depending on. For a convex lens, it can be positive or negative, but for a concave lens, it will always be negative because it always form. It will be always positive because it always form virtual and direct image. Okay. Have you got this? For a convex lens, M can be positive and negative. For concave lens, M is always positive because concave lens never form the real inverted image. Have you got this? Or it is formed. You have seen in any case that the concave mirror lens is forming a real and inverted image. Have you seen? Done? By using
Sir,
these
I'm
three
getting
for
refractive index as minus 1.5.
minus 1.5.
Yes, sir.
Have you taken convention?
Yes, sir.
What is the focal length is coming out to?
The focal length I'm getting is minus 1 by 12. Minus 12.
How the focal length of a convex lens be minus? Have you got this?
Sir, one doubt.
Ah,
Object distance is minus 30, right?
yeah,
And image distance is 20 plus 20.
yeah, yeah.
Yeah, I'm good. Let me check it.
And where the minus is coming, all become positive. Have you got this, beta? Afif, stop chatting. Okay, it's not you. And who is he? Get focused. Okay. Have you got this, beta? I have given you the formula. You just have to put the values and find the answer. What's the problem there? Okay, let me rub this. After the class, if the class get over, I will send you the link again. Now, combination of lenses. When the two lenses are combined together, what the nature or what the magnification, what will be the net focal length, that all we need to see. Okay, that is called combination of lenses. Combination of lens.
Sir, one doubt.
Yeah, bro.
Sir, R1 is 10 and R2 is minus 15, right?
One is minus, one is positive.
Okay.
Combination of lenses. If the two lenses are combined in such a way that their surfaces are being combined in this way, then what will be the combined effect of this will come out? These two lenses. This is their optical centers. Okay. So if there is an object at this point, the light ray which is being passing straight move like this. At this point, it will bend somewhat like this. Okay. And at this point, again, it bends somewhat like this. And the image get formed over their final image. Bye. Okay. But here, if this was not the case, then the image due to this was forming at this point, let us say I dash, which is V dash, and this is V. Okay, and this is U. The object are these are very thin lenses, so we can neglect whether their centers, or we can let them their centers are coincided. So we can let these two distances are from the same points, all the distance. Okay, whether it is V dash, V or U. Can we say that? Then what we can write the focal length for the first length? Focal length, it is having a f1, it is f2. Then what will the focal length f1 for the first length? 1 over V dash minus 1 over U. Okay. Similarly, focal length of the second lens will be how much? 1 over V minus 1 over V dash, because this V dash, this image due to this lens will act as an object for this lens, second lens. Have you got this? Now, if we add these two equations, first and two, we get, what do we get? 1 over f1 plus 1 over f2 is equals to 1 over v minus 1 over u. You get this thing? Do we get this? Isn't it? Okay. So what do we take this? If it is being a lens which is being forming the image of an object kept at a distance u from it, at a image distance from this, it is forming somewhat like this. This is V. Then its focal length Fe, or combined focal length Fc, you can say, is being 1 by Fc is equals to 1 by V minus 1 by U. Have you got this? The combined effect of this being written is in this form, that there is a lens which is forming an image of an object kept at a distance as same as it was in this case, forming the image over here in this case, as it was same in this case. So it is having a focal length as equals to the focal length of these two lenses. Sum of these two lenses, we can say that. And 1 by f, we can say this, Fc combined focal length. And combined focal length for these two lenses can be said as 1 by f1 plus 1 by f. If there are many lenses are combined together, so we can write up to 1 by fn. Okay, have you got this, beta? Yeah, the combined focal length of these two lenses will be the addition of the individual focal lengths of all the lenses. Have you got this? If you see, there is a lens which is making an image of an object as same as the distance was over here, and the image is being same as the distance over here from the lens. Then this, the focal length of this lens will be same as this. So we can write from here.
Sir,
Yes, beta.
sir, it is not direct addition, right? We are doing reciprocal addition.
Yeah, reciprocal addition. That is written over there.
So can you tilt the phone little because I cannot see the last line.
Now can you see?
Yes, sir. Yes.
Can I rub this?
Yes.
Then what will be the power of the lens? Next heading is power of the lens. What it is? Power of the lens. What it is? It is the ability of lens to converge or diverge the light rays. Okay. It is an ability of a lens to converge or diverge the light. Have you got this? Have you got this or not? Depending on its sign, positive or negative, you can find that how much the power is being there, or the unit of the power is. What is the unit? Diopter. Capital D is being represented in the form of. Have you got this? So by observing the power, you can find whether the lens is nature of the lens. If P is positive, the lens is, or before that, if you know the relation between focal length and power, then you can determine. So the relation between focal length and power is
P equal to 1 by F.
P is equals to, for a lens, it is for a P is equals to 1 by F. Okay. So if from this, if you see power